Hi folks, welcome to another set of 8th grade science video notes. Today we're going to learn all about the periodic table of elements. The purpose of the periodic table of elements is to organize the elements into an easy to read and easy to find format. Everything in our known universe is made up of a combination of these 118 elements, so it's really important for scientists to have them organized. Dmitri Mendeleev is credited as being the first to create a periodic table of elements. His looked a lot different than ours does today, since there were only about 30 elements that we knew about during his time. His system was so good, however, that he was able to accurately predict the properties of undiscovered elements. In fact, he predicted the density of the undiscovered element underneath aluminum, and then a Frenchman came along, discovered the element, and named it gallium. When that happened, Mendeleev wrote a paper explaining that the Frenchman was wrong about the element's density. Now this was pretty crazy at the time because Mendeleev has never even seen gallium. The Frenchman has found it, studied it, done calculations and experiments and all sorts of stuff with it. And without having seen it, Dmitri was so confident in his periodic table that he wrote a whole paper saying why the French guy was wrong. And after they did some more experiments and testing on it and maybe argued a little bit, they found out that Mendeleev was actually more right about the density than the French guy was. There are 118 squares on a periodic table. Each one corresponds to an element. In each element square, there's always a good bit of information. Some periodic tables have more information, some have less. And sometimes the information is in the same place in the square. But if you know what you're looking for, you should be able to read it clearly. Generally, each element square contains a name, a symbol, an atomic number, and an atomic mass for an element. So let's zoom in on the element hydrogen here. You'll notice that the full name of the element is written here on the square. There's also a letter, which is called the chemical symbol. A chemical symbol is just an abbreviation of the element's name. The symbol is always 1 to 2 letters long, and the first letter is always capital, while the second letter is always lowercase. On this periodic table, we can also find the atomic number. As you know, the atomic number is unique to each element, and it describes how many protons are in the nucleus of one atom of that element. The atomic number is always a whole number with no decimal afterwards. The atomic number, in my opinion, is one of the most important bits of information on the element square. Finally, we have the atomic mass. This is similar to the mass number, but there's a little more work that goes into it than just protons plus neutrons. The atomic mass is how much 1 mole, or 6022 with 23 zeros afterwards, atoms of the element weighs in grams. This is almost always expressed as a number with a decimal afterwards. So now let's look at some geography of the periodic table. We have the vertical columns, which are called groups or families. There are 18 of these, and we call them groups because the elements are grouped together with elements of similar properties in their columns. Next, we have the horizontal rows. These are called periods because they have what's called periodicity to them. In other words, as you go from left to right and then go down a row and left to right again, you notice a pattern of repeating properties in the same places. There are 7 different periods. The periodic table is organized just like you'd read a book. The elements are put in order of increasing atomic number from left to right in a period. Then we go down to the next row and keep adding to the atomic number as we go to the right. There are 3 categories of elements. We have metals, nonmetals, and metalloids. The metals are usually shiny, ductile, which means you can stretch them into a thin wire, malleable, which means you can hammer them into thin sheets, and they're good conductors of electricity and heat. You can find all of the metals to the left of the zigzag line on the periodic table. Next, we have the nonmetals. This is almost everything else in the periodic table. Nonmetals are often dull, brittle, and bad conductors of heat and electricity. They're all found to the right of the zigzag line, with the exception of hydrogen, who's up here on the top left corner. Lastly, we have our odd little group of metalloids. These have properties of both metals and nonmetals. For instance, silicon is a metalloid that is shiny, but it's also very brittle. These are found on the zigzag line. You might notice there's a lot more brown than there is blue or pink on this periodic table. The metals make up a little bit over 80% of all of the elements that we know of. The periodic table is so perfectly organized that we can actually see some interesting trends when we look at it. For instance, the density tends to get bigger as you go down in a group, and it also tends to increase as you go in towards the middle on the periodic table. For instance, osmium, the most dense element, has a density of 22 grams per milliliter, while hydrogen, the least dense element, has a density of 0.09 grams per milliliter. The size of an atom, as judged by its radius, tends to increase as you go down into the left. Francium is the largest element with a radius of 348 picometers, while helium only has a radius of 140 picometers. You already know the atomic number gets bigger from left to right, and it gets bigger when you go down. But did you know the atomic mass generally also increases the same way? This should make sense because as you add protons, you add to the mass of your atom. The elements with the highest atomic numbers, or the ones clear down here in the bottom right, also happen to be the elements that are the most radioactive. Well, that's it for your notes video today. I hope you were able to learn a lot about the periodic table.